But just before that, I'll hand you over to Chris Lawrence, who's our branch secretary, and he's arranged another talk in June, to which we'd like to invite you.
Yes, we have an online meeting scheduled for June the 8th. It's called Environment and Social Governance Metrics, and the speaker is Ian Hodges, and it really results from an article that has recently been published in the European Business Review, and the talk is on metrics, environment and social governance metrics, and he will explain his view and understanding of this. He says managers need to understand this. They need to understand what is required to report the metrics meaningfully, accurately, and efficiently. So we look forward to that talk. So back to you, Imo.
Yeah, thanks. Of course, I've misattributed you. Chris is in fact our branch treasurer and former chairman.
Yes, sorry, I didn't spot that.
I'll stop messing things up now and get out of your way. So over to you, Sofus.
Fantastic. Thank you, Imo, and thank you everybody for joining. Yeah, welcome to. This is my talk, Better, Faster, Stronger with DevOps, but how? And I hope during the next hour that will make it more tangible for you what DevOps is, how you start with it, and why it matters. So my name is Sofus Albertsen. As you probably can hear, I'm not from England. I am based in Copenhagen, born and raised in Denmark, and I'm the Academy Headmaster from the company Efficode. So let me just see here. We are a right now Northern European based or Central Northern European based company. Just today we acquired a small business in Switzerland. So now we are in 8 countries, 350 professionals. And we have the tagline, building the future of software development. But for me, the tagline that I live by and the academy where we are having all the training and knowledge sharing is that we don't chop wood, we sharpen axes. And we want to sharpen people's axes instead of going out and chopping their woods. So when we are out helping people, we want to give them the tools that we have in order for them to succeed. It's much more fun for me to teach somebody to do my job than to do it over and over again. So yeah, I come from the academy part where we have a lot of different trainings, courses coming up. So we do all different kinds of things, but mainly inside DevOps, Agile, Atlassian, Cloud. So all these different things. We were a continuous delivery company before, but now we have expanded over to DevOps, Atlassian, also design and UX and accessibility. So enough about Efficode. The agenda for today is that first I want to talk about what is DevOps, because DevOps is many different things compared to who you ask. Then I want to talk about the business case of DevOps, because it actually matters, especially when you're talking to your managers. Then I want to talk about the DevOps practices, what it is that you actually do, the tangible things, adopting and scaling DevOps. And then after that, I hope that we can have some good Q&As. If you have any questions regarding the things that I say, please write them into the chat. Then I'll try to weave them into the presentation as well. If you at some point during the next hour get what's it called, amnesia, and don't know what happened, this is the summary. So companies doing DevOps are more profitable. DevOps is easy to explain, but very hard to do, or hard to do at least. And culture eats DevOps and DevOps changes for breakfast. And last but not least, flow and technical excellence is key in the adoption of DevOps practices. But enough about that. I want to first get a feeling around who I have as the audience today. So I created this small Mentimeter. I hope that some of you have seen this before. If you haven't, then please go into menti.com, so the URL that is up here, and use this code 79249357, and just write in your job title or the thing that describes what you work as or with the best. And I'll try to give this 1 minute to see who we have here. All right. I can see that at least it's working. Fantastic. Fantastic. I like that we have so many different people from the software development organizations. So software engineers, clearly the majority, then come students, then we have different kind of developers in software developer, software engineer, yeah, ALM engineer. Good. So this tells me that we are all pretty technical around this. So I'll try to keep it in that level, not go too much into nitty-gritty details around the wording, DevOps, and all of that. The next thing I would like to see is, and this is anonymous, so don't be afraid that that I can track down on who is saying what. But I would like to see how fast are you delivering change. And the definition here is from a developer commits code in your software, and it's done from the developer side, to one of your users can actually see the change in your software. How long does that take? Just give it 30 seconds more. So we have some people who are doing it very fast, and then we have a lot of people that are having up to a month or a couple of weeks and then longer than that. Good. So the pain points that I will talk about today, I hope that you can see that you can recognize yourself in some of them. The last thing that I would like to see is that if you experience problems with any of these 4 things, I'll give you 30 seconds again. So new hardware, if you want to have that it takes ages to acquire for your team, that you have problems with environment drifts in dev test production, resulting in errors that are not something with your code, but something with the hardware and the availability there. Tensions during handovers, where developers are throwing something over the wall to operations or anything like that, or that QA, security, let me just give 10 more seconds. QA, security, and all these things that tend to come at the end, they get squeezed at the end of the release cycle. Okay, fantastic. All right, so what this tells me is that hardware is pretty, we have an IT department that is pretty fast, but the problems that we do seem to get is at the end of a release cycle, where all the other people after the developer committed his or her code, that we have some problems there. Thank you so much for participating. This gives me a lot of insight. So I will not take this one now. Will you take that afterwards? So, good. First, a little bit of a history. And I know we are all IT developers or IT professionals. So this will come as, I hope this will come as no surprise to you. We have Edgar Dijkstra, who said at some point, as long as there are no machines, programming was no problem at all. When we had a few weak computers, programming became a mild problem. And now we have gigantic computers, so programming has become an equally gigantic problem. The phrase "it works on my machine" comes to heart. It's easy for me to develop something on my computer and it works. It's a little bit harder to get it to work on my colleague's machine, and it's even more hard to get it to work to the thousands of computers that need to serve this every single day. And we, at the beginning, thought that we were building bridges, that we should do everything in a waterfall manner, that we should do design and requirements and all of that, and then only first at the end do the testing, just like you do with a bridge. You can't really test the tonnage of a bridge before you've built it. But are we really like building bridges? When we did that, we also came to the conclusion there was a lot of different big programs that were failing. I don't know the United Kingdom examples here, but I know Polsag from Denmark, which was a case management system that costed us around 70 million US dollars and was never working. So we have a tendency to spend a lot of money on big, well-intended programs that never or rarely get into use and does not fulfill the wishes that we have. So software is not like building a bridge. We do not have well-defined requirements up front. Every time we do some new software, it's an iterative and exploratory way of doing it. When a user sees a new feature, maybe he or she will then think of another feature that they also want. Our software does not have the same function throughout its lifetime, or rarely have the same functionality. We do upgrades, we do enhancements. We also do deletions of some of the lesser used features. And our surroundings are not static. If we look at the bridge, we know where it's coming from and know where, like, the start and the end. In our software, we can't really see that. If we have external connectivity towards different kinds of services, we can't really make sure that these are not changing either. So we're not having a static surrounding. And we are not building with well-known materials. We are not building with a programming language that has been invented since the 80s, and we are still only using that version from that point in time. Every time we are doing something greenfield, we tend to look at the newest technologies and see, can we adopt them? Because they promise some greater flexibility, some high abstraction levels, et cetera, et cetera. So none of these that characterize building a bridge characterizes the way that we are building software. So here comes DevOps. The basic thing of devs and ops, which are like the abbreviation developers and operations, the way that we can, the first image that are when we talk about DevOps is the chronicle conflict between what developers are doing and what operations need to take care of afterwards. So developers are normally incentivized for change. How fast can you deliver a new feature? And then throw it over the wall to operations, where they are incentivized for how much 90 percentile of or 99 percentile of stability that they have. And if operations do not know what it is that they get thrown over the wall, then they have a tendency to say, no, I don't want to deploy this because it's on my watch if something goes wrong. It's me who's getting called up at 3 a.m. in the morning to fix something, and I don't know what you did. Especially if it's still a manual thing where you send off an email with a bar file to the operations people saying, please deploy this on the Tomcat server. I've seen this out in the wild, and it's if I were the ops people, I would be scared if I'm going to exchange one var file to another. So there's really this delivery flow from developers to operation, but not really something back again. And they're incentivized for two very, very different things. But yet they are, if you look at it in a holistic point of view, they are serving the same purpose. They are serving the application. They are serving the customers for this application. But they were still having this conflict. And to make matters worse, they are not in the same team. Maybe they're not even co-located, situated in the same place. One of the big companies that I was out helping, they were in vastly different locations in the same city, which meant that they rarely or never talked towards each other. which meant that all these different kinds of small problems that you normally could stand up and then just go over and talk to your colleague over there, you won't do. If you're in different buildings or in different floors, tendency are that you don't want to do the travel. So we have this blame game between developers and operations. Developers are thinking that the operations are always these naysayers and don't really know what they're doing, and operations are having sort of the same thing with developers, that they are too trigger happy to release or release happy, and they take too many chances. And this is not good. So we want something where those people are together and we have a flow of delivery instead, that we don't talk about what the developers are creating and what the operations people are hosting, but what we can deliver to the customer. And there's a lot of different new abbreviations for DevOps, DevSecOps, or DevBizOps, or Dev QAOps, and they're all the same thing. If you are working in a product or for a product, and you are QA and somebody else is a developer, then doing DevOps as a team means that you are in the same team. If you're responsible for the QA for a given product, then you need to be in the same team as the developers. You need to have the same goals as the developers. So it can be boiled down, DevOps can be boiled down to this comes from just humble. So it's about the culture that you have. It's about automating. It's about removing waste, lean product management. It's about measuring your changes and what is good and what is not good. And it's about sharing knowledge and responsibilities. So the first thing that you can do is acknowledge that we are having one holistic system here, that it's not only the developers are doing something in the silo over here and operations are doing something in the silo over there. Every time I say developer and operation, you can insert any one of the others, QA, InfoSec, whoever it is. We need to figure out that this is a flow, and if there's a problem up in dev, they don't pass it down to ops. They take ownership of their problems. So we don't pass down things that we can see are error prone. That's the first thing. Have this system thinking where everybody is on the same train and you are stopping the release train if you find any errors, even though it's not on your table. The first thing that we do when we go out and talk to a customer that wants to do something with their developer, like with their DevOps in journey, is that we create a map of all the different processes, from a person gets the requirements and creates them to the end user sees the result. And then take at least one or two for every team that are involved in this and figure out how do they collaborate, where are the problems, where do we have queue, wait states, where do we have manual work, where do we have conflicts. And usually the way that the people who are working with the value stream here, they tend to have a different view than what the managers are thinking that the people are doing. And just getting people together and drawing this map resolves a lot of conflicts, or at least gets a lot of conflicts up in the air and make them tangible for people to do something about. Because then we at least have the same image around what is happening from a requirement getting born to a user actually seeing that. The next thing is trying to close the loop or amplify the feedback loop, saying that every time we have an error in production, the developers also need to know that. And we need to make them also part of the people that are responsible for the uptime. And we also need to have the the operations people to talk to the developers. How easy can it be for them to include some more monitoring, some more measurements, all these different kinds of things, some more logging at different places, so that those two are tighter together and that the problems of operating your application also becomes the developer's responsibility. And when you have this feedback and strengthen that with more tests, with more monitoring, with more logging, so you're more confident in that what you release is actually what is good enough, then you can start the last but very, very important part. You can start doing continual experimentation and learning. Instead of thinking maybe this feature could be good, you can actually build a hypothesis around it, saying, let's try to make this as a minimum viable product and get it out there. And then let's see how our customers are affected by it, whether or not they're using it. Maybe let's just have a button that denotes the new feature, but we don't implement it. And if a user clicks on it, we say, hey, yes, we have now acknowledged that you want to use this feature. We will send you an email when it gets ready or implemented. In that way, you are less error prone, and you're more deciding on what you need to do by the feedback that you get from your real users. It's sort of the same as having a baby. I have a 3-month-old girl back at home, and I can see that her feedback loop is very, very instant, and she fails all the time, but she also learns in the same pace. And the same we need to do now, because sometimes we have a tendency to say we should never implement a feature that nobody will use or won't be a success. And I can see that if you only have like one shot, one chance at hitting it, then you really better be right. But if you can make small adjustments all the time, then it's okay to be wrong, because you can just take it away again, and then you can learn from that. So reducing the feedback loops, again, from a developer commits code to a user getting it back to the developer again, seeing was it actually a success, that is paramount to this. And DevOps is not really something new. Hate to break it to you. It's building on top of the shoulders of many other giants. It's around agile, it's automation, it's the lean that comes from the Toyota factories, it's system thinking, the scientific method, continuous delivery, resilient engineering. All of these different kinds of things are within the umbrella of DevOps. And I think also that's the reason why there's not one term for how DevOps is and what DevOps is, but more likely a many different varieties. It hasn't been invented by academia, it has been invented in the industry. So why should we care? Why is this a good business deal? Because there's a lot of different things that we could invest in, but why should we invest in DevOps? We can ask ourselves the question, if we get good at DevOps, do we get more money? And luckily, there's a lot of different research on this, especially from the institute called DORA, which is the now getting been acquired by Google, with the PhD statistician Nicole Foskring. So what they do is that they survey every year. They survey thousands of companies throughout the world in order for them to figure out, if you're good at DevOps, are you also making more money than general from your or than the average of your sector and your size? And they came out with these 5 metrics, or 4 key metrics, and availability, in order for them to say, if you're good at these, then you are also making, then the chances of you making more money than average in your sector are higher. So it's lead time, change failure rate, deployment frequency, time to restore, and availability. And I will go a little bit more into it, but I really recommend you, everyone, to read The State of DevOps. It's a fantastic piece of literature and very easy to read. So availability is measured as the percentage of time a system is available with normal service. So we have the blue line here where we have normal service, and then at some point our service becomes unavailable or impaired. And we just need to measure this. This is a very standard way of measuring. We have done that a lot of different times. This only applies to applications that needs to be available, because there's also applications that only needs to be there in batches, and then availability is not one of them. That's the reason why that's not a key metric, but the other 4 is independent on sector and size. Stability is measured in two ways. How long time does it take for you to recover from releasing a faulty release in your system? And how many times out of all the releases that you do you introduce some kind of error that makes your service unavailable or impaired? So here from version 3 to 4, everything was good. There was no stability issues. From version 2.4 to 2.4.1, we had a service impairment or an unavailability in our service. So it took us some time to recover from that. Throughput is measured also in two metrics. So the release frequency, how often do we release, and our lead time from commit to deploy. And again, commit to deploy is from a developer thinks that he or she is done with the feature, that it's ready for production, to that it actually is in production and getting used by some end user. Sometimes the deploy to production, the very last thing over to the customer, can be discussed whether or not that's included, because some customers do not want to have a continuous deployment at their place. And also, if you're making mobile apps, for example, Facebook is deploying their app many times, but they're not releasing to their customers many times a day, simply because we don't like our cell phone to get a new version of Facebook every single hour or every single minute. We don't like to download new things. So they make the last release switch every once in a while. But everything up until the release switch, which is a very small manual step, is automated. So all of these gives us the ability to meet or exceed our organizational goals, and our organizational goals can be translated into money. And people that are good at this are very much better at doing a lot of different things. So if we compare the elite group towards the low performers, we are 208 times more frequent code deployments, etc. I won't go into these numbers. You can read them in the release from them, the 2019. So what does all of these things enable? Well, they enable that we can do the experimentation, as I said before, but we can also delay our decisions on whether or not we should go with a specific version of a library, if we should implement a certain feature to the very latest point in time, which means that sometimes we can also say no to a thing that we thought that we were going to implement. And that means that we can both save time in not implementing things that we can see now are not needed, but also that we can take advantage of the latest and greatest, or at least the knowledge that we have now, compared to taking it like a year before or half a year before. And we are able to scale both up in terms of when there's availability or when there's a surge of customers, but also down, keeping our maintenance low. So what do these high performers do differently than the low performers? I've put it into two different categories: the technical practices and the cultural practices. If we look at the technical practices, they use the cloud extensively. And when I talk about the cloud, I do not mean that you need to use AWS or you need to use Azure or any of the other cloud providers. No, you can have cloud internally as well, but you need to uphold to these characteristics of the cloud. Your on-prem services need to do these different characteristics in order for you to call it that you can have an on-prem cloud. Your team needs to be able to have on-demand self-service. So again, no ticket to IT, 14 days of wait time, and then some kind of ticket gets resolved. No, you need to be able to order things automatically and get it provisioned automatically. You need to be able to do it many different places, and broad network access here does not mean that you need to have high-speed internet on your cell phone, even though there's a 5G logo here. It means that it needs to be not gated in on that particular machine over there that is the only one who have access to that particular network. You need to be able to access your infrastructure and your network and your test facilities in a very free manner. That not being said that it shouldn't be secure, but there's many different ways of securing your network that has nothing to do with wired connectivity. Then we need to be able to pool our resources, and this is more towards the IT department. They need to be able to pool your resources together or your requests together with other requests in order for them to save both bandwidth and hardware costs. So if you order a big server but you do not use it, they need to be able to scale you down accordingly. And that also comes with the rapid elasticity. So again, you only order what you need, and then have the ability to both scale up and scale down if usage is higher or lower. And then last but not least, with great power comes great responsibility. If you are able to on-demand self-service, take whatever you want, order whatever you want, you also need to be measured on it afterwards. A lot of different companies that are going into the cloud, the first thing that they do is that they make a root account, and then they give the people that want to play around with it a sub account to that root account without talking about the measured servers. At one place that I've seen, one guy went in, ordered the biggest server on AWS, installed Minecraft on it for the weekend just to try it out, but forgot it during after the weekend, and then the month after when they got the bill, it was around $5,000 or $6,000 for that machine alone that have proven them zero new ways of doing things or new capabilities. So please make sure whenever you're starting your cloud journey, also think about how you measure these things and how you build alarms into it so you don't end up with a $1,000 bill for nothing. The other thing that they do is that they invest heavily in automation. Again, in the report from DORA, they have asked these low, medium, high, and elite performers what they do, whether or not they have automated builds, automated unit tests, etc., etc. And this gives us a pretty good idea around what is the majority investing in and what might not be so important for elite performers, or maybe it's not matured enough yet. So almost everybody in the elite performers are having automated builds. I think it's higher than 92, but again, the statistic shows that it's 92%. So here you can clearly see that there are some things: automated build, unit test, and automated provision and deployment to testing environments. But these three things are crucial to them, and are also, at least to the automated provisioning part, is differentiating the low to elite performers quite a bit. So here you can see what kind of automation that the different sectors or the different groupings have invested in, and how much they're using that. Another thing that they also invest a lot in is the continuous integration. And continuous integration is that you at least once a day sync up with the rest of your team code-wise. That does not mean that you need to push your code into the mainline branch, but that means that you need to sync up. So at least you need to take in the latest from the mainline. But it also means that you need to be able to build and test what you do, again, to get feedback. So your pipeline needs to be there. So you are integrating every day. We are building on every commit that we do. And even though that might be expensive in the short term to do, to enable all these different kinds of builds, it's so much cheaper to get a machine to build your code than it is to have a person fixing it at 3 a.m. in the morning, because your users are looking at a bug. And we have this always green state of the mainline branch, so it's either called master or main, that we are fixing immediately. So if there's a broken build on main, the person that introduced that particular commit that made that particular bug have a window of 10 to 15 minutes to fix it or revert it, so we again get a green light and then fix it off mainline. And that's the beauty about building every commit, is that you can spot the bad apples when they get introduced, and you can quickly take them out again. Where if you only build them occasionally, there's a lot of different people who have added commits, so you don't know which one of them added the bad apple in the bunch. We also, or they also use loosely coupled architecture, so they are easily available, able to change out if their payment system needs to be different, or if there's a new service getting introduced, that we don't need to re-architect the entire infrastructure. I am not a software architect, so I won't go too much into this because your mileage may vary and I'm not the expert here. And then we give the teams the autonomy and the responsibility so that they can test, deploy, and change their system once altogether. So again, all developers and operations people about this or around this application needs to be together and have this responsibility, but also the capabilities to do this. If you are in the financial business or in the military sector or in healthcare, you might say, or embedded ones, you might say, well, this does not apply to me because I have law, I have embedded things. It might be good for web development and mobile development, but not for me. I have a news for you. It's the science, the fact shows, the statistics shows that industry and technology stack does not matter. Only your architecture does. So across all sectors, there are elite performers in financial businesses, there are elite performers in the military section, defense sector. The only sector that have a impact or a change is the retail business, and they are better than average in DevOps. All others are not, but the architecture have a clear impact. I want to briefly talk about Devops tools because some vendors tend to say that they have a Devops tool, especially, for example, if you are talking about Azure, they have a piece of software called Azure Devops. And I just want to say Devops is not a tool. Devops is a collection of capabilities, and you can also do DevOps in Azure Devops. But installing Azure Devops on your server does not mean that you are doing DevOps. It's just a name. But there are some capabilities of these tools that we want to look at in order for us to be able to do this so agilely and so rapidly. We want our code version controlled. Right now, it's Git that is the de facto standard. Unless you are doing games or other things with big, large binary files, then Git is the de facto standard. We want automatic testable code. What kind of test frameworks that you use depend on your libraries, your languages, and your environments, but we want it to be automatically testable. We want your infrastructure as code. And again, whether or not you're using Ansible or Terraform or Kubernetes or whatever it is, it doesn't really matter. You just need to have these capabilities in order for you to spin up your application and service over and over again in a concise and uniform manner. You want your runtime and your dependencies as code. Again, Docker right now is, or containers are right now the thing, but it can change whether or not that's the technology that we're going to use. And we want release pipelines. We want continuous delivery, continuous integration, and also continuous delivery, making sure that we have a releasable product at all times. Maybe it's not the latest code that is releasable right now, but at least we have something that is releasable that is fairly new. And then we want unified logging and metrics, making sure that our application is discoverable and we know what is happening to it. Also, how our users are able to use our application. So that's the technical part. If we look at the cultural part, that is actually what have been getting the most attention for the past couple of years. because DevOps started as a technical thing with Flickr coming in and saying that they deployed 10 times per day in a agile conference, and that started it all. But right now we're focusing a lot on what impact the cultural practices that we use matters to the ability to achieve these goals, the organizational goals. Again, having decoupled teams, having teams that are autonomous is really, really important, that they are able to change things if they see that things do not work, or they're able to test things out if they have new ideas. If we look at how our organizational diagrams are looking right now for a conventional company, it can be that we can see that, again, testers are over here in one side and developers over here, and then operations people are in a different silo. And that also means that we do get these very hard decouplings between these different kinds of people. Also, if we have multiple backends, they're also very decoupled if the teams are also very decoupled. So Conway can have the Conway law, where we say any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So again, if you divide two teams, but you still make them responsible for the same application, you will also, within the architecture of the code, see these two divisions, even though it's not natural for the application to have that. You will see strong interfaces that rarely changes, and you will see tight coupling between the two teams, or within the two teams. And that's not good, because then we are having managers deciding how our software architecture looks like, ending up in something that is not the right way to do things. So we need to be able to create our teams the way that the code needs to work, the way that the code needs to communicate with the rest of the world. And then we need to focus about psychological safety. Again, I want to have a brief Mentimeter from you guys. So let me do like this, and then I have this one. Well, okay, so already somebody have been in there. So I have a couple of questions here. So in your company, is information actively sought? So are you talking towards people? Are you inquiring how new things can be done? Are messengers punished or not when they deliver bad news? Are responsibilities shared between teams and between persons, or is that always that person over there that has the responsibility for the uptime? Is there cross-functional collaboration? Is that encouraged and rewarded? Is failures causes of inquiries, or is that? Are you able to use the voting here? I don't know. Yes, you are. Fantastic. So let me just give you another minute here. And are failures treated primarily as opportunities to improve the system? So are you able to say that a given failure is a chance for you to improve, or is that more scorched upon? All right, I'll just give you a couple of more seconds. I don't want to give you 40. All right, so we're actually doing pretty good. I think the worst one is the messengers are not punished when they deliver bad news, that you can shoot the messenger. The responsibilities are not really shared as well, or at least for some of you. And then failures causes inquiries. I mean, when things get hot, we tend to shout at people. And then the last one that for me at least, that thinks is very important is that when we have failures, that we see it as a way to do things better. So thank you for that one. Let me just see here. Yeah, so I will not go into that one yet. So please do not fill out the next one. So Google made this a fantastic survey again, because they wanted to figure out what made the impact of their best performing teams. And what they found out is the psychological safety is the #1 denoting factor for a high performance team in Google. And psychological safety here is that the team member feels safe to take risk and be vulnerable in front of each other. Being able to say, I failed, I forgot, I learned something new, I'm sorry. Or being able to go on and say, well, I think it might be, I have an idea, let's try to test it out. In the Accelerate book, which is a whole book that is denoted towards showing why these state of DevOps reports statistically work, they divide organizations into 3 cultures. So the pathological one, where again we have low cooperation, messengers are shot. We don't want to we tend to be in our ivory towers and not really helping each other. And then we have the little bit better, but still not good enough culture, where we have the bureaucratic rule-oriented one, where everybody have their designated places. And if it's within my power and also within my benefit to help you, then I might be able to do that. But otherwise, you need to talk to my manager in order for me to get you to help me, or get me to help you. So there's still some cooperation and collaboration, but mostly we just tend to stick to ourselves because that's what the rules are saying. And then we have the last one, where we again look at this more holistic, saying, okay, does it benefit the application or the business that I help this particular person, even though it's not my primary job? Is it better given out that I use my time helping there than to do my own things? If yes, then I will do it. If no, then I will maybe try to help figure out if there's anybody else who have time to help the poor person out. So we are taking a common responsibility and common risk taking in order for us to improve the system. And we want to welcome feedback and inquiries to new ideas and suggestions. This is best shown with an example, I think, and that's the GitLab nightmare. I don't know how many of you know, but the 1st of February 2017, GitLab.com was down. GitLab, for those of you who don't know, I think everybody knows, but it's a competitor to GitHub. And back in the days in 2017, they were very much an up and coming Git hosting provider. They have this tweet: we accidentally deleted production data and might have to restore from backup. Google Doc with live notes here. So what happened is that they, throughout the next couple of days, methodically and very openly described how a software developer, team member #1, had deleted the production database for their system. So, damn. And they tried to utilize one of their 7 backups. That one didn't work. The next one didn't work. The next one was not implemented correctly. The next one was corrupted. And throughout the next 3 days, they fought and fought and fought, and eventually they were almost up and restored back to full service. But some people never got their code back. Maybe they had it like because Git is a distributed database, but still there was a lot of different things going on here. They could have just shut up and said, we have a minor service outage. We will come back to you later with information. But here they were very open on what didn't work and what failed to operate correctly. You might think that the users of GitLab would be furious. I mean, if I were owner of a software development company and I couldn't use my Git hosting provider for 3 days, I would be pretty mad. If I lost code, I would be furious. But instead of having a lot of different people leaving as customers, they actually got sent in both money and cakes and pizza and cookies. And there were even these t-shirts, I am team member #1, that got printed and given to people. Because we all know these operation stories of people or things that got wrong. And instead of thinking, why did team member number one, why did he or she delete the production database? What they did instead was asking the question, why were team member number one able to delete the production database? Why should a team member be able to perform this operation that is so lethal towards the company and does not have a real profitable positive user story for it? So instead of punishing the person, they went in and said, well, the process is wrong. We need to adapt the process because nobody should be able to delete the production database in this way. And the transparency here really shows how you can change a failure into something that was actually positive towards them. The last thing that I would like to show you before wrapping up is a small piece of fantastic document from the Department of Defense over in the US. So they have a lot of different guides, and I really love many of them because they're very thorough. This one in particular I like. The headline says it all, Detecting Agile BS, because I don't think that there is any company who will not say that they are agile. It's sort of the same thing if you're a company right now saying, no, we do everything traditional waterfall style, then you are not here anymore. But are we really everybody doing real agile? They have this wonderful diagram on whether or not you're doing real agile or not. So questions like, are teams delivering working software to real users every iteration, including the first, and gathering feedback? If not, then there might be some things that you could do in order for you to improve that particular thing. The other thing is feedback from users turned into concrete work items for sprint teams on timelines shorter than 1 month. So do we gather feedback and are actively using that to create new software features? I'm not saying that if you are saying no to any one of these, then you are not doing it right. I just say that this is a beautiful way to ask yourself, can we do this better? So this DIB guide, Detecting Agile BS from 2018, still holds water. It's very fantastic and comes with tangible ways of improving. So last part, I forgot this one, adopting and scaling DevOps. When you are on your journey automating things, then you are having this curve as the amount of manual work when you're starting automating that goes down. But at some point, it will feel like it goes up again, that the amount of manual work that you do is increasing even though you're automating things. And don't be afraid, this is perfectly fine and normal. The reason for that is that when you start automating things, you also start releasing more often. Therefore, having more of the manual work that is left getting duplicated. So that means that you, at some point, actually will feel like that you're doing more manual work now, even though you have automated things than you did before. And this causes a lot of friction and tension when you start this journey. But don't worry, you will, when you keep on automating, end in a place where you have a lot less manual work. You also figure out that the things that you start off automating maybe were not automated in the right way. Maybe your architecture was not able to automate that in the right way at the first place, and then you need to re-automate or re-architect your automation. So at some point it will go down again, but you be mindful of the J-curve here. And remember, you are all special. It just doesn't matter. Again, depending on sector, depending on team size, depending on company size, we can all be better at achieving these organizational goals and being better at DevOps. And whether or not you're having financial businesses or sector, what's it called, heavily regulated sectors, it doesn't matter. You can all do these different kind of things. Of course, you need to do something different if you need to uphold to certain standards. but you can still improve your DevOps metrics, and you can still measure them in order for you to approve it. We all have different things that we do. I mean, if you're making a product, that is what makes you special. But at the end of the day, we're all releasing one way or another. So, a summary. If you want to do something, focus first and foremost on building a healthy culture. The reason why I put this as the first one is because it's one of the hardest ones, and it's also one of the things that is forgotten the most when we look at DevOps. We think that we should automate everything to begin with, but maybe our biggest problems is having the culture and having the communication pathways that we need. And then we can automate afterwards. Automation is easy. Having clear change processes, making sure that everybody knows how the change is flowing through the different teams and the different places in the organization is very valuable. And also figuring out where things are going wrong, where there's constantly tension, where there's friction. So having a clear change process is good. Your value stream orientation. Again, look at this. Look at this as a holistic whole point of view. Get people together, talk about it, form teams based on the responsibilities and the people that need to talk together the most. Form smaller teams with smaller responsibilities if needed so. And prioritize technical excellence. I haven't really said this out loud, but having all these new capabilities and new tools also requires you to be proficient in those tools. So making sure that you have knowledge sharing, making sure that you are doing courses and training, making sure that people are up to speed. So again, that they sharpen their tools in order for them to be efficient is key. So this is the 4 takeaways. And now I am done talking and would like to get questions if there is any. Thank you for listening.
That was a really excellent introduction. Thank you very much, Sofus.
No.
While we're waiting for people to come up with their own questions,
Yes.
I've got one for you.
Mm-hmm.
I work in a regulated environment for healthcare at the moment in my current project. We're an infrastructure team which is basically responsible for making sure the platform exists to support the applications that are running there.
Yeah.
And when we started, we were able to release whenever we wanted to, and we had to because there were things that came up really urgently. But as time has gone on, more and more sort of QA and assurance teams and security teams and so forth have come into the place. So now we find that it's not possible to get all those people to approve a release more than, say, once every 2 weeks.
Yeah.
What do you advise organizations to do in those situations?
Excellent question, Imo. So I have a slide that I haven't added here, but if we look at the development process and the release process, we tend to get this lump at the end where we have, just like you say, the QA people, the security people, the configuration management people, and all of that. And we need to try to shift some of these responsibilities into the loop. So one of the new things, for example, is that you want to build security in, not by saying that you need to think about security from the start, because of course you need to do that, but that you need to automate some of the security. So maybe one of the things that the security experts in your company are doing is that they are vetting the dependencies that you have. Well, these types of things you can build into the pipeline so that every time there is somebody who makes a commit, you will also have these checks. So we want to shift as much of the manual work and automate that into the pipeline and into the process to make sure that you get these fast feedbacks. And then we still have some things left to do at the end, but we need to take a good hard look at it and say, okay, but how much is there left? Can they, if we automate a lot of these things, can it be that they just need to have a report that they need to say, yes, these things have been performed, now you're able to release. It's not a overnight fix, but shifting things from manual, especially for example QA people. Many of the larger organizations that I've been in, QA gets this exe file or whatever it is, this binary file, and then they hammer on it for 2 or 3 weeks. But normally the 3 weeks that they need gets boiled down into 10 days, and then need to take weekends in to do this. If you couple a developer together with one of the QA persons, looking at what the QA person does and replicating that in the automated pipeline, then you're doing it not once per release, but every commit. And that saves time and gives more confidence.
Yeah, absolutely. I totally agree. And you do have to make use of the tools that are available. So all of our deployments go into Amazon Web Services, and they provide you with things like config, service, and what's it called, Trusted Advisor,
yeah,
and Security Hub, and loads more. So you can actually automate this. What it still means is that we're deploying stuff into a staging environment, and then we have to give it a few days for all these automated tools to run, and for the various approval bodies to come along and say, okay, that's provided the evidence, you can now promote that into production.
But like my experience is that if you change from that a person doing a lot of manual work to a person checking that the things have been performed, then you are shrinking the time you need to wait in order for you to release a lot, and you're also reducing the tension for the people that are coming at the end of your release cycle, that all of a sudden they don't have the time that they need, but they have half the time, but they need to still put their name into the full application. So you're reducing the burnout as well doing that. But of course, again, some places it might not be worthwhile going all the way, but it's nice to know what good looks like in order for you to say, okay, we have at least reduced it from a month to 2 days, and then we know from a structural point of view that we are actually able to release right now. But whether or not we can, that's a different political or organizational decision.
Great, thank you very much. There's a question here from Philip Moore. I've enabled everyone to unmute themselves if they wish to actually speak.
Okay, because I can't see the chat or the questions there. So it's very good if you read them out loud.
Yeah, Philip, do you want to unmute yourself? If not, I'll just read out the question. When trying to move to a DevOps model. Oh yeah, are you there?
Yeah, I was just curious, when people are moving to these sort of models, what's the biggest mistake people make? What wrong turn do they tend to take, or what thing do they spend too much time looking at, or does it not really matter? Is it just more important just to fail fast, keep moving, try to iterate towards this sort of model?
I think we tend to be, again, very tool loving, so that we throw all different kind of things into the game without asking ourselves the question, okay, can we actually measure whether or not this have a positive impact on us? So again, the beautiful thing about the DORA reports is that they're giving us 5 different metrics that we can go in and say, okay, can we measure these things right now? If we can't, then we need to do that first. We need to be able to measure this, and then afterwards we can take the scientific approach. And then I think the thing that have puzzled people the most is that just making a virtual machine on AWS does not mean that you're using the cloud. That just means that you are building your virtual machine on somebody else's computer. And I think those things going the layer below and saying, what kind of capabilities is it that we need? Why are we doing the things that we do, instead of just saying, well, I mean, I've thrown all these different tools in it. Yeah, did that answer your question?
Yeah, thank you.
Yeah, no problem. And good one.
You didn't really cover the question of metrics very much in your talk. Do you have any views on it?
I don't know what you mean about it, but I think the reason why I'm yeah.
How do you measure things like throughput and
So again, I mean the time to like you measure your deployment lead time, for example, is easier to go backwards and saying, okay, now we have released. What type of things have gotten into this release, and what was the first thing that we worked on that we have released right now that haven't been released before? So normally when we are making our what's it called, our release notes, for example, we can look at these things and say, okay, which one of these Jira tickets have been the oldest one, or which one of them have the first commit over here? Looking at that. But it's a non-trivial thing to do this. It's not again, you can't have a tool that's just that you just install and then it gives you all these different kinds of metrics. There are a lot of different tools out there that will help you if you configure them correctly. My company Efficode having one of them. But there's no quick fix here. So you need to take your application and then look at how do we get these metrics out? Because again, it depends on whether or not you are doing embedded software or you're doing mobile applications, or how much you're utilizing ticketing systems and the traceability there. But I hope that you already now have, for example, availability info somewhere gathered, and then you need to take those metrics in and say, okay, can we make this into a graph that is constantly updatable and not only something that you do every once a month? The deployment lead time, again, first can be manual surveyed, and then afterwards you would like to know, can I make a script that will tell me these different kind of things? But you need to have traceability in order for you to do automation. And if you're not tagging your Git commits with a Jira issue, for example, and you're not having the Jira issues in the release node, then you don't have that traceability path. Then you need to create it first in order for you to do the automatic measuring for it.
Yeah, I can definitely confirm that you know, tagging commits with Jira ticket numbers is extremely valuable. We've done this a lot. Also, AWS gives you, and I guess all the other cloud providers give you a lot of things like metrics that you can then formulate alarms on those metrics, and then you can see historically how long each alarm was in the alarm state.
Yeah, and then again, I mean, sometimes, at least when you're using the cloud, then sometimes you get more alarms than what is needed, and then you need to figure out, okay, so in all my logs, is every warning a degradation of my service, or are there just some warnings that are sometimes popping up because of one reason or another, but does not impact the end user, but it's just something that we need to ignore. But that takes a bit of a while. First gathering all the metrics that you have, and then looking at what you have.
Okay, we have a question from Ernest Atta. Do you want to unmute yourself?
Hi, Sofus. Thank you very much for this exposition.
My pleasure.
So my question is, I come from the data protection background, but I've been hearing DevOps with the buzz noise and all that, and it's something that I've, like you said, it's easier to say DevOps, but it's easier to practicalize. So my question is, what would be the starting point for someone who maybe he doesn't have IT or coding or software background from data or that desires to become DevOps practitioner? What would be my starting point from your ask?
It's a good question.
Your background is data protection, is that right?
Yes.
Yeah. So it really depends. So I'm a software developer by education, but I very quickly found out that I was a mediocre software developer. So that was not where my competences should be. I think that what makes a DevOps consultant or a DevOps practitioner important is that we do a little bit of here and a little bit of there. So I am a master of none, but like a Swiss Army knife that is not really doing anything exceptionally well, but knows the plethora of different tools. Good things to learn about is version control systems, automation platforms like Terraform or Kubernetes and Docker, and CI systems like GitHub Actions, Jenkins, Circle CI, GitLab CI. So I think that's the place where I would start if you're going in the technical direction. And the other part, if you're going in the more cultural, it's around team management and creating high performance teams by psychological safety. So there's a lot of good resources on that at Rework, which is Google's study case website.
Rework, R-E-B-O-K, you mean?
So actually, I think that's the next slide that I have here. Yeah. So RE:work.
Okay. That's useful. So what you're saying is there are also non-technical, is what you mean. I mean, like you said, DevOps can apply in any organization. It doesn't matter whether it's software. Like I used to tell where I work that if we have other teams working together, it's also the same thing DevOps is talking about, for us to have this integration. If the other team, let's assume marketing and HR, they don't have to see themselves as working in a silo. They should work together to achieve the same aim for the organization. Is that the kind of thing DevOps is trying to achieve also?
If I understand you correctly, then yes. But I think that in order for you to be a DevOps practitioner, you also need some of the technical things. But you don't need to be good at writing code. But you need to know the basics of any coding language, so anyone can do. And then making sure that you know how is software getting released. So which kind of processes are there? Even though you are working more with the cultural part, because it's all about the delivery flow here.
Good. Thank you very much.
Yeah, no problem. So, Imo, do we have other or?
Yeah, there's two more questions. One from Ravi Karelia, who's ready to speak.
Yeah.
Hi there. Thanks, Imo. Hi, Sofus. Thanks for this great overview. Question I've got, and it's not really an easy one to answer, but I work as a program manager I've been doing this for many years. So where an organization is looking to bring DevOps in, you always get this tension in terms of senior management wanting things done like yesterday versus allowing the time and the space for all the things that you've really pretty much covered, allowing those time to bed that in. I mean, is there, I suppose, are there any studies or stats around typically how long it takes for an organization to adopt a good DevOps capability if they're given the time and space to do so? Because from a senior management perspective, it's very much about needing delivery like yesterday, and it's about managing expectations as well.
Yeah. So very good question. I don't think that there's any of these metrics out there saying that it will take you 3 years coming from this particular place, because it also really matters, as you say, like all of this matters in how much management is willing to invest in this. Like how much do they think that this will actually be better in the future than what they have right now? So that they can switch, or that they can tolerate a lower throughput for any given point of time, but then gaining that afterwards. And it's the constant battle that you have. I think that what I see is that when companies are starting to involve or to embark in their DevOps journey, what they tend to do is either taking one team and trying to make, or taking one product that is fairly well functioning, and then making that the pilot project for it, or they are making a DevOps team which can be good in a transition, but is not good as a permanent structure. but a team of people that are dedicated in helping the other teams progressing in their automation and all these different kind of things, because it is easier to get advances in the technical side than it is to do in the cultural side. Yeah, but there's no metric saying it will take you 5 years or 2 years. It is a journey, and a lot of companies have these maturity models where we tend to see, okay, you start at the level X and then you go forward. The problem with those is that they end at some point, and with the current way that IT functions, there is no end state. We always keep evolving. So measuring your maturity within an index that is bounded towards a given part of level will make you have the impression that at some point you can just relax, and that's not it. If you are very good at this, you constantly keep learning and keep pushing yourself.
No, that really helps. Really, for each organization, it's about, I think you touched on it earlier, which is, first of all, make sure you're able to measure the key metrics, because without that, it's very hard to then demonstrate any change. And then the examples you've given, maybe, go with the team and then just see for that organization how long it is taking them, and then use that as the basis, yeah, for future work. So
yes.
That's helpful. Thank you.
Yeah, there is a website called Team Topologies, or you can Google Team Topologies, that talks about how to do DevOps in team wise, but also how not to do it. So I recommend you that website if you want to form a way to start off this journey in your company.
I can definitely endorse that recommendation. One last question, please, from Sean.
Thanks, Sofus. That was a great presentation. My question is, I work in an organization that provides cloud infrastructures for our customers, and we have a dev team and we have an operation team. And basically, my question today is, how do we find a balance and we don't end up doing more of operation works rather than the development works? I'll explain that. So basically, we work with iterations. So we have the sprint work that we're meant to do within each iteration, and most of the time we find ourselves having to juggle to go on the Kanban board for the operation team because we're getting a lot of questions from our customers and we had to provide support. So my question is, how do we find a balance and we find ourselves not finding ourselves doing more of a DevOps work, more of an op, and we're not developing anything due to support that we provide for our customers? Thank you.
So are you in the development team? So as I understand you correctly, you have a development team and an operations team, right?
So I'm a DevOps engineer for the organization I work for, and we provide service offering. And within those service offerings, one of our roles is we have to provide support for those service offerings, those accounts that we provide to our customers. We have sprint work in each iteration, but most of the time, because of the demands and the requests and incidents from the customers, we'll end up leaving the sprint work, the development work, to focus on the operation works, most of the time providing support. So my question is, as an organization, how do we create a balance so we don't do
Yes, now I understand what you're saying. So I think you would benefit from reading upon how site reliability engineering from Google is defined. So DevOps and site reliability engineering are almost two sides of the same coin, but they're just coming from different angles. What Google is saying is that we only want to do a certain percentage of what they are calling toil. And toil is manual repetitive tasks or firefighting, or these things that are preventing us from doing improvements. And every time we hit that certain threshold, we need to get more people on board. So what they do in a developer and operations team is that they say, well, the operation people can do certain amount of toil, and when that ceiling is hit, then all other developers need to go over and help them automate things or fix things. What I hear is that you also have so it's a chicken and an egg problem. It seems like that you haven't been allowed to focus enough on automation and securing your reliability. So therefore you are firefighting a lot. And one way could be to go away from Scrum and iterations and then over to Kanban and saying we can only work on X amount of things at the same time. But there you are still not addressing the problem of firefighting all the time instead of improving the system. And for that, I think site reliability engineering could have some angles on how to tackle that if your management allows you to do that.
Thank you.
Yeah, no problem.
Terrific. I think we'll draw a line there because we're coming up to 8 o'clock. Before you go, Sofus, I would like to share my screen and
yes.
Let me see if I can do this.
I'll see if I can. No.
I need to make myself a presenter, I think.
So now I have unshared my screen, right?
Yeah.
It's the first time I use this GoToWebinar.
Oh, I was showing the wrong thing. But I can drag the thing in. So the point about this is that I wanted to express our appreciation to Sofus for the work he's done to prepare this and to provide this particular talk. And I cannot see the window that I'm trying to show. This is awful. Sorry about that.
It's the demo guard emo.
Yeah, I had this window open before, and I think what's happening is that the yes, here we go. All of the windows that are opened by GoToWebinar, we're covering it up. So this is the book that you've selected, and it's not out yet. It's coming out in July, but we'd like to present you with that. It'll be sent to your home.
Fantastic.
To provide an address to the, to the BCS groups to send it to. So very interesting choice. Can you explain why? Yeah,
because I've seen them times and times again, if we have diversity in the place that we work, we are better at fixing problems. So not only women in technology, but also old and young people and people from different cultures. If we work together, we have different angles of viewing and therefore come up with better solutions. To me, being a auto mechanic or a software developer is sort of the same thing. It depends, like the culture there can be very male dominated, and sometimes it can also be very, I don't know what's it called, a garage humor. We called it in Denmark. I don't know if it's translatable. But if we have several people from different backgrounds, we tend to be more aware, and also there come up with better solutions. So that's the reason.